And welcome to Dynamics 365 Finance and Operations OData and Custom Apps, High Performance Integration Scenarios. Um, my name is Nathan Klaus. I'm a technical architect for Invista. I'm also a Microsoft Business Applications MVP. Here's all my contact info. Feel free to reach out if you have any questions on anything finance and ops related or related technologies at any time. Just let me know if you need help, and I'll do my best to help out. So these are the topics that we're going to be talking about today. I'll hit on a few of them. So every time I do a presentation, I like to have a theme in my deck just to sort of keep it light because I cover some pretty dry topics. So this deck is my meme themed deck. Some of them might be funny, they might not be, but they're there. So hopefully, at least one person gets a laugh out of it. The audience for this presentation will be primarily technical architects, senior devs, to mid, I guess all developers really. But this is very technically focused. We're going to be reviewing code, testing, some visuals related to telemetry gathered. So this is a very heavily focused technical session. So if that does not describe you, you may not get a lot from this, or you may be lost at times, but just want to call it out. First, when we're talking about OData, we want to define what problems we're going to look at, what is OData good for and what it's not good for, and make sure that OData is the right tool to use for whatever it is you're trying to integrate, whatever problem you're trying to solve with an integration. Also, just some other considerations, how OData entities are a little bit different than just your standard data entities, and then we're going to go through our, sort of 4 key areas: read performance, insert, update, and delete performance as well. Before we get started, here's all my sources from stuff that I've coded up, made visuals for, written on, or if you just want to reach out and say, hey, I have a specific question, as a follow-up to this conversation here. There's all my stuff, so feel free to check that out. All code in this presentation is available at the first link there, so if you see anything you like, don't just screenshot what's on your screen. Just go there and you can clone the repo and do whatever you want with it. So first, really when we talk about performance, we want to gather requirements for, what is our required level of performance? What is acceptable? What isn't? So as for instance, I've got this outside system and I want to make a customer in less than a second. Can we do that? Is that 1 second, SLA time, is that a hard requirement, a soft requirement? Someone just said, yeah, I want it to be fast. Is there some other part of the system that is integrating in that has some specific performance requirements for this action has to take less than this amount of time, or the integrating system breaks? There's a lot of stuff to talk about there and really define what needs to be fast and what doesn't, and how we're going to account for that, and speed up areas that need to be fast and other areas that don't need to be fast. Maybe that's a batch process, or we use this, that, or the other process to just have stuff happen in the background. But really, we need to gather requirements about what it is we're trying to do. Who's defining those requirements, specifically around performance, and then anything else that needs to specifically be called out. So if we have any consultants on here, when you're talking about a performance or a system that's currently in place, there's a lot of little minor things that clients may accidentally leave out because it's just been that way for 5 years. And this is where we gather up all those little tiny things where it's the exception to the rule, or whatever that may be for the specific system, and just call those out. And then make sure that really OData is the right, the right option for whatever it is you're trying to integrate. Next, you want to talk about, workloads. So like, what is it that we're trying to do, and is there potentially another solution that would work better? And I think a few of you can see where this is headed. Yes, we're going to talk about DualRide very briefly. But, what kind of specialized workflow is this OData integration supporting? Is it, a new customer gets created through some website integration, and then now it needs to go out to this other app to qualify the customer, to validate some info, or whatever the case may be? Is it a portal for customers and vendors to go in and see the status of all their orders and shipments and all that stuff? Or is it a workspace? So let's say you don't want to do EDI integration in a traditional sense with a van. You just want to say, here's a portal, customers go into your purchase orders there, we'll get them and process them, and you can check on your statuses there too. So you really have to think about how is it going to be used, and then when we get into the next, I guess, design of it, think about what needs to be fast, what doesn't, and we might have to have some specialized entities to support specific types of workloads for different integrations. So, I mean, really questions that we need answer to are, I need to get X in less than Y milliseconds, or update or insert or delete. But really the question we need to answer is why, and is OData a good fit for that? So now the next question, what about DualRide? So DualRide is a great option if you want to use stuff over in the Power Platform. And yes, I corrected a mistake there. This is Microsoft documentation. I fixed a branding issue. But DualRide is a great option if you want to do stuff with your data from finance and ops in the Power Platform. We're not going to be talking about that today. We're going to be talking about specifically integrating via OData endpoints to finance and ops. If you want to integrate with the Power Platform or Dataverse, there's a different set of SDKs and endpoints you can use over there to support OData integrations, but that's not going to be talked about today. If there's any interest in that, feel free to leave a comment, and we'll see what we can do. So next, what is OData good for? In simple terms, it's basic CRUD operations on declarative data entities. So you have to have a data entity in order to do OData for that data entity. And you have to include any customizations for your instance in all data entities that you've added, fields for. So as a, for instance, if you added some fields to sales table and threw it on a form, you still have to go back and add those to your data entities that you use that data source. Next, postings in general are not supported with OData. You can make it do stuff with custom code, but if you want to post some kind of transaction, typically not, OData is not a good solution for that. And in simple terms, I explain to clients, think of this as like a spreadsheet or list management. And the reason why is OData is what's used by the Excel add-in. So whatever you can do with the Excel add-in, in really simple terms, you can do here with OData through a custom integration with like a C# based web app or whatever the case may be. So next, what is OData not good for? Data extraction in bulk. For this, you'll want to use the DMF with BYOD or export to data lake when available. But in general, if you're asking for more than 10,000 records via OData, there's probably a better solution for that problem. There's a lot of supporting technologies for that. Again, posting transactions, you want to use a custom service or an out-of-the-box service. Anything in the Power Platform, just use DualRide. If you want to extract anything on a schedule, you can use the recurring integration framework or the batch data framework, and you can even use the batch data framework with change tracking to just have changes trickle out on a schedule with flow. Or if you need to react to something happening, I created a new customer. Use a business event and use Power Automate and to move that along to the next step of where it needs to go. Whether that's in Power Apps, some other third-party system, but if you're going to react to something in F&O, you want to, in general, use a business event. Other considerations to think about is when we start digging into some of our tests and the various data entities and various concepts that I've tried out, you're going to see me review stuff based on developer environment, a local VHD environment, and a UAT environment. The reason why is when you're working on a developer environment, I just want to call this out, here's F&O on my server somewhere out in the cloud, and here's SQL right next to it. If I take a look at the next infrastructure slide, so this is the old VMware-based infrastructure, now it's all going to Service Fabric. But you can see F&O is here on this server, and SQL is over here. Now there's very little, there's going to be some distance between those, and that doesn't necessarily affect performance in aggregate, but it's just something to consider that, there's going to be a very, very minor spike in network lag because there's some distance between them. Now it's not going to be noticeable a large majority of the time, but I just want to call that out. So next, the difference between a data entity and OData. So there's very little difference in general. You have to set public to yes, and then it turns it into an OData entity. Other than that, really just click that yes, and you have to fill out two properties that are going to have to be globally unique. But then, you can turn a normal data entity into an OData data entity. Some of the things you need to consider about with OData is you want to optimize them for OData usage. So consider that OData is more of a faster path to get to your data. So you'll want to optimize for that and not have row-based operations in there in any sense of the word. Try and use sets whenever available, or just work with one record at a time. And these do have to, in general, enforce more business logic and rules because it represents a different entry point to the system that may be covered by some other class or something along those lines that does not get executed as part of a data entity workload. So, your tests for this should include DMF testing, X++ testing, and C# testing. And just as a call out in case anyone didn't know, when you have a data entity, you can treat it just like any other declared buffer. So if I have sales order, I think it's sales order header entity v2, I can declare that and just call it record. And then I can treat that like I would any other buffer for any other actual table. So it's sort of cool. But, confirm all entry points, give the same result when working with OData so that you have consistency across all of your different entry points and how that data entity could be used. So I'll pause briefly for questions if we have any. Otherwise, I'll hop right into read performance.
We don't have any questions yet, Nathan, so you can continue.
Okay, thank you. So next, we're going to talk about read performance. This is the biggest and most visible area when using OData, and it probably represents a bulk of the workload for a given integration. And the reason why I say that is, in general, you have to scope your record before you can update it. Confirm it's there, and then I'm going to perform some update on it or delete it. So let's say you've got a hypothetical integration that's just going to go in and update all your customers every night. Well, that sounds like a 100% update workload. It's 50% find to scope the records, and the other 50% is update to update the records. So if it takes forever to scope a customer, your updates being passed really don't matter because put the two together and it's slow. And some things that, scenarios to think about are when you're using a customer portal. So let's say a customer goes in, they want to get a list of their orders. That's a set-based read. I select one. That's an individual-based read. I bring up the details for that. Again, it's an individual-based read, and then I go in and look at the related details for pack lists, or pick lists, pack slips, invoices, whatever the case may be. So I'm doing a lot of reading just to put data on the screen. Another example would be a customer workspace where similar sort of workload, but they're updating stuff as well. But you've got to get your list of sales orders to find your one sales order to perform an update on it. So next, just in general, you want to avoid data entities are complex. These are just the short version of a lot of things that I've discovered. So if you have fewer columns, your data entity in OData workload will be faster. Same with if you have fewer tables or joins in there, that'll be faster. One thing that I discovered is the read-only attribute on a data source or a data entity is just there for functionality. It has no performance, and we'll actually see that it has a negative performance impact when compared relative to other stuff. It's sort of interesting to see. Anything that you can make happen faster for one row means that it'll happen faster when you have 10 or more rows. And just as a call out, rows and sets behave differently. So you'll see some very interesting numbers on some of the tests I've run. So here we're going to just hop right into, this is just a visualization I put together. So just to get an idea of what read performance looks like. So this is on tier 1 development environment. I set up a bunch of different data entities that represent a bunch of different things I wanted to test. They were all largely based on sales order header v2. I did 100 random reads from a list of declared sales orders across all of the sales orders and organizations inside a Contoso demo data set. And just as a call out on here, we've got random and repetitive. These are two test types. You'll notice that my numbers are basically the same, so we're going to just ignore the repetitive test set. But the light blue line represents a random read based on an unknown number, and the dark blue is I'm just asking for the same record over and over, just as a looped request. But first, we're going to take a look at, this is sales order header entity data source read only. This is where I marked all of the data sources on the entity itself as read only. And then I just grabbed a bunch of records. And you can see that, on average, it took 223 seconds from start to finish to get that. So that it represents our slowest one. So I took an out-of-the-box entity and made it slower by making it read only, which is interesting. Next, same sort of thing, except I made the entire entity read only rather than the individual data sources in it. So again, it's faster than the last one, but still slow in general relative to our next one, which is this is the out-of-the-box data entity from Microsoft. This was tested against 10.0.13, so not the latest and greatest. But you can see I just took a copy of that and made it read only, and it got slower. So sort of interesting. So just, I'm not really sure what to draw from that other than read only makes stuff slower. So it's just there for functionality's sake. So next is another out-of-the-box entity. This relates to addresses. This just changes a join type. It's again, it's faster than sales order header v2, but this does not support creating new addresses when creating a sales order header. Next is sales order header v2. So this is a copy of sales order header v2 where I marked the entire entity as read only and removed all globalization. So anything specifically related to stuff that was not related to US operations. So this was tested against USMF data only. I got rid of sales table underscore W, sales table underscore BR, and base document underscore IT. So again, it's faster by removing some data sources that were all empty for my workload, but it still was faster because they were gone, even though the comparison was, it was, slower when they were there but empty. So again, less stuff means more faster. Next, I just took the sales table entity and made a, sales table, made a custom entity on it, marked it as read only, and that's just a data entity that is just sales table and all of its fields. This supports read only operations. And the next is the same exact entity. It just supports all CRUD operations. And again, it's somehow faster than a read only entity that is exactly the same. I just flipped that one property. And then lastly, I took a sales order header v2, made a copy of it, and removed all data sources that were not sales table and all code related to that. This supports full CRUD operations. But you can see, so if I back up, on average, it took 205 milliseconds to get a sales order header from F&O using an out-of-the-box one. I removed all the extraneous stuff not related to specifically sales table, and my, I got a 400% performance increase. So, again, less equals faster. Another, thing that we found is, don't use subselects. Microsoft does ship some entities with subselects. Those are in general not bad. And there's a few rules to that, but in general, don't use subselects if you don't have to. For those of you that don't know, every data entity that you create gets boiled down to a SQL view, and you can go ahead and look at that SQL in SSMS if you want. Views can contain subselects from other data sources or really anything, but these can and will kill your performance. So I've got a few examples I want to walk through. So here is sales order header entity v2. I'm sorry, v2 entity. So this ships from Microsoft with this bit of code in here. All this does is write a bunch of SQL for you. So this gets turned into this on the SQL side. So this isn't a terrible subselect. So if we have any SQL people on here, I'm just taking one number and throwing it in a case with a bunch of other logic and converting one number to some other number. That's not terribly bad. It's not the best because this is now a row operation rather than a set, but not terrible. So we can live with that. What you don't want to do is something like this. So this is, I've got a subselect on a data entity that uses a stuff operation on a non-deterministic record set based on an item and data area lookup. So first things first, I skipped partition in my lookup, which will throw your index usage a little bit out of whack. But I don't know what I'm going to get back with this. So it could be that this adds 1 millisecond to my read operation. It could add 400 or maybe even 4 whole seconds. I have no idea. But there may be instances where you need this, where you don't care about read performance. But in general, this is a bad idea because you don't know precisely what you're going to get. And it's in a stuff operation, which is an XML operation, which is not the most performant things in the world sometimes. But this is an example of a correlated subquery. So where I've got some part of the query that relates to something outside of that query. So if this were just select number of sales orders from sales table, regardless of customer number or sales status, just get a count, select count star from some table and have that on my data entity. That'd be fine. But this is a correlated because it has filters from outside of that subquery, so SQL has to knock it down to a row-based operation, especially for this because of the stuff operation. Next, you can use a select when fetching data. For those of you who don't know, so using a select on an OData entity just instructs the entity to only give you specific fields back rather than all fields in that entity. But using a select will give you performance improvements when working with sets, so that's more than one record, and performance degradation when you use just one record, and we'll walk through that. So here again, I've got a set of tests, and I wanted to draw out the network lag that we're reducing by removing the amount of data that has to go from point A to point B. So we've got different point A's and point B's, and we'll walk through that. So first, we're just reading 10 sales orders from the sales order header V2 entity. If I back up for a little, I just want to call out the light blue line is going from a tier 1 box to the same tier 1 box. The dark blue is going from a VHD, so hosted locally, to where I am right now, to a tier 1 box. The orange line is going from a VHD to a VHD, so all local network traffic. So here I'm getting 10 records, and you can see how long it takes on average after 100 tests to get those 10 records. And just as a call, I did verify every result set did have at least 10 records that were included in here. So we are comparing apples to apples. But if we're going to take a look at, let's focus on just the light blue line. You can see it took on average 346 milliseconds to do that with no select. That's just, I got 10 records 100 times. Here's some performance counter. Next, I did the same exact test, except I specified a select to get the only five top fields. And if you look at the sales order list page, it's basically the fields on that list page that were available in the entity. So you can see number one, performance was better. It took less time. And most of that was related to just having to send less data. So sort of interesting. So if you want to use a select when working with large groups, you can do that and you can get some performance benefit. However, next, I'm going to read just one record with that same select statement that I had in my last test. And you'll see it actually takes longer to select one record with a select on only 5 fields, rather than this test, which is I'm just grabbing one record with all fields. So, again, sort of interesting numbers. So when working with sets, selects make sense. When working with individual records, selects do not make sense. And really what's going on here is select is an extra step that doesn't happen normally. So when you throw that in there, you're asking the AOS to do extra work that slows down performance. But then the benefit of that is you don't have to send all this stuff out. So the AOS doesn't have to package 115 fields and then send that to its destination, and then the network lag that you would acquire from that. So You're doing a little bit more work on one side to get more performance benefit somewhere else. But with working with only one record, that just doesn't pay off. Again, same sort of data set, and we're just looking at how quickly the values from the different environment types and the different distance between the environment types paid off. So I'm going to sort of breeze through this. But in general, going from a VHD, so basically my computer here to the cloud, that's where we got the most amount of benefit from using a select. But depending on what your integration scenario looks like for where your app is integrating from and where FNO exists, that you may see similar or better results. You may see not quite results that don't amount to anything. So it really depends on what's between your integrating app and FNO. So next, we're going to talk about some more performance tricks. If you have to use a filter as part of your query, you want to filter on your underlying data sources indexes. This sort of goes without saying, but keep in mind that if you don't disclose who, where those indexes may be to the consumers of your entities, they're not going to specifically know. So, just keep that in mind. If you hand off data entities or data entity endpoints, say query on, these fields, these are my index fields, so you'll get your best results here. If you're consuming data entities and you don't know a specific index, just specify everything you can and let SQL figure it out. It'll do a good job 95% of the time. So let's just look at some data. Again, 100 tests with the sales order header, V2 entity, fetching one specific record based on one specific criteria type. So here I'm just grabbing one record that belonged to warehouse, I think it was 01. This is not an indexed field. I'm just grabbing a sales order based on some criteria. And I want to call out a few things here. Our top orange line represents our max value. Our dark blue bottom line represents a minimum duration. And then, at the top of the bar is 246, which is our average after 100 tests. So you can see on a non-indexed field, I've got a high amount of variability. That's the difference between the orange and dark blue line. And that's something that, from an integration standpoint, we don't want to see. I want to see consistent results. But I don't have an index here, so I shouldn't be doing this. Same here. The email on a sales order header, not indexed. I'm going to have some wild results. Same with sales order name. You can see from left to right, our numbers are increasing in general in terms of performance. But still, these are not index fields, so that could just be relative shape or size of the Contoso data. But again, you'll want to test with your data, and all the code is out there for you to do this. Lastly, same on Invent site, we've got a huge amount of variability, even though in an average scenario it is relatively decent performing. But then next, this is on an indexed field. This is on sales order ID and sales type on sales table. You can see my variability is quite low. And overall, it performs better than all of the lookups on fields that were not indexed. So this all makes sense based on how we know the indexes work. But now you can sort of see what this means for OData in an OData workload scenario. So next, we're going to do the same set of tests, but we're going to do it against a set. So we're going to have 10 records. Sorry, we're fetching 10 sales order headers from sales order header V2 rather than just one record. And similar results. So, we've got a lot of variability on fields that are not indexed. In general, they're relatively slow. But then when we get over here to, again, this is on sales ID and sales type, we have a very small amount of variability. In fact, less than 10 milliseconds. Less than 20 milliseconds. My labels are flipped. And overall, it performs significantly faster than all of the other ones before. So again, indexes matter, and declare those indexes if you are not going to be the consumer of your own OData endpoints. So next, we've got the average duration when we're looking at a workload on specific declared entities on sales table. So not all indexes are created equal. Some indexes, especially in an OData workload, are better than others. So what we're looking at is I'm doing lookups on the specific fields that tie to specific entities, or sorry, specific indexes on sales table using sales order header entity v2, just to see which index is quote unquote best performance. So here we're doing an index on the customer and created date of the order. This was a bit of a shock to me. I figured a date being included in a index would make it relatively fast, but I was wrong. So again, we fetched 100 records and used lookups specifically on this entity. I'm sorry, specific to this index, which was cust-created index. And then next, same sort of tests. We're just testing against the status customer account index. This index was not unique, but it was in general performed better than our last set of tests, but not by much. Where we start to see performance difference. So the next 4 entries are all unique indexes. So here's just a plain old read. This is just on sales ID. So I had a data area ID and a sales ID passed in. And first of all, callouts are variability. The difference between the top and bottom line is much smaller. It performed better than our last 2 tests, which were not unique. And overall, just relatively good performance. But where it starts to get interesting is when we start to get into the extended types. My assumption going into this was that reading based on a sales order ID and data area ID, which is unique, would be the fastest, and that is not the case. So next, we're doing sales order ID plus sales type. So all I did was specify a sales type, and that ended up being marginally better than looking up sales order or just sales ID and data area ID. So sort of interesting. Next is, I call this the read garbage operation. This was a wildcard I threw in there to just specify a bunch of fields, not specific to any index. I actually specified a lookup that contained a lookup from every index that we're looking at here to see what SQL would do. And it mostly got it right. So, I specified customer, the accounted date, the status, sales order ID, sales type, everything that's represented in all other indexes here. And with throwing everything at it just to see what would stick, I got pretty decent performance numbers, but it wasn't my best performance numbers, which is sort of what I would expect. So, SQL made a decision and you use some index based on the workload it was given. It guessed good, it didn't guess great. But, I didn't specifically, if I'm just a consumer and don't know about the underlying data source indexes, I just gave it everything and said, figure it out for me. And it did a pretty okay job. And then lastly, again, just doing 100 reads based on a customer ID. And that ended up being our best performing index. And truthfully, I can't spell why, or explain why. Could just be the size and shape of the Contoso data, but this was a bit of a surprise for me. So, again, test with your data, see which indexes work best for you, and use those indexes. Next, we're going to talk about use of order by. So you want to limit the use of order bys. An order by is a way to arrange your data prior to it being sent to you. So you're asking the AOS to sort the data for you before it gets sent. And in general, you want to avoid using that. And just as a call out, some of the findings here were a bit surprising to me. So I want to say it's based on a limited data set from Contoso and test with your data. So here again, we're doing reading 10 from sales order header, a V2 entity based on specific queries with an order by descending or ascending included in that. So, in our first test, we're reading 10 records with an order by descending, not on an indexed field. I think it was just email or something like that. I don't recall the specific field, but it didn't perform great. So, I was selecting from customers, ordering by sales name or email, something like that. And, that was nearly 400 milliseconds to get that with an okay amount of variability. Next, I did the same test, but except I flipped my order by to be ascending. So that's asked it to do more work. And we're sort of seeing that with the variability here of our workload. Next, this was a bit surprising to me. I actually had a calculated field. So this was a subselect that was there and shipped with the entity. I just used it. When querying on that, that performed marginally better than just fields that were just data fields. And I can't really explain that. I'm not sure why. I'd be interested to know if we have any SQL people on here, why a subselect would be ordered by faster than just plain old data, but who knows. Similar here, I've read 10 based on a calculated field and added an order by descending, and it performed pretty okay. But lastly, here we're doing a read 10 with an order by descending on an indexed field. So in aggregate, it did perform better. Descending operations are going to be more work than ascending operations, typically depending on a bunch of different things. But lastly, here we did a read 10 with an order by ascending on an index, and if the index is I'm drawing a blank on the type. If it's a particular type, that's just how the data will be arranged on the disk anyways, so you're not actually asking it to do much work. So that previous workload was based on a developer environment. This is what we're looking at here is the same set of tests run on a UAT environment. So in general, you see stuff takes a little bit longer because it's going from where the application was running right here local to me and going out across the internet and hitting a UAT. I think it was US East. So relatively close geographically to me. I'm based in Detroit. But you can see, in general, stuff was slower in aggregate, and our variability on some of these is significantly higher. So, in general, don't use an order by unless if you absolutely have to. And the recommendation is, once you've gotten the data, once the consumer has gotten the data based on a plain old read with basic criteria, throw that into some iQueryable .NET thing and sort it there after you've got it, because .NET can do it faster than the EOS can, because .NET will have it in memory and the EOS may not, maybe using temporary tables or something like that. I'm entirely sure. But again, you'll see our two fastest performing tests here were based on indexes. So if you have to use an order by, always do it on an index. Next, we have just read performance and multi-threading. This was just something that I thought would be fun to do. And I'm not going to read through the bullet points. I'm just going to show the slides here for what happened. Again, I created a test where I created one thread that fetched 100 sales orders at random, and then just started stacking up my threads to see what would happen. So this is what it looks like from a developer environment. This is specifically a local VHD on my computer that is under my desk right now. So you can see as I threw hardware at it, stuff got better, but it didn't grade. It doesn't necessarily scale well. And just in general, do not do this. The reason why I say do not do this is, so this is from a developer environment. You can see I got up to 500 threads, and that basically killed everything, but stuff still worked. It was just really, really slow. Here's from a UAT environment. You'll notice that the number of threads stops at 100. UAT environments have some kind of throttling mechanism that development environments do not, that prevent you from doing what I tried to do, which was spin up. I actually tried to go to 1,000 threads just because I wanted to see if I could crash IIS, and I couldn't. The UAT environments, probably tier 2 and above, no one volunteered their production environment for me to break. They have some controls in place to prevent you from doing stuff like this, where dev does not. So just, again, another design decision where just because it works in dev doesn't mean it'll work in production. But again, you can see as my thread count went up, my overall lag and the overall amount of time it took for stuff to just happen went up with it. So next, we're going to talk about expands. If you aren't familiar with what an expand is, it's a way to go from like a child record to a parent record. It's really cool functionality. But as a call out here, sort of similar to the multi-threading, these will appear to be slower on a tier 1 or development machine and will actually be faster on a tier 2 machine, which is sort of wild, and I've got some data to back that up. So really briefly, if you're not sure how to use an expand, here I'm looking at the sales order line V2 entity. That has some relations that relate back to another entity. I can call expand on that specific data entity when interacting with my sales order line V2 entity, and it'll bring that other entity along with it in the result set. So sort of really cool functionality. So when I'm looking at the performance for this, this is just a set of workloads. So again, I fetched 100 sales order lines at random, including the expand operation, not including the expand operation, and including two operations, one to get the sales order, and then one to get the sales order header, sales order line and the sales order header for that sales order line. So now in a developer environment, you can see my worst performing workload is the read expand. And then next is doing two actual different operations to get my data. So get my sales order line as one request, get my sales order header as the next request, and that actually performed better than an expand, which I thought was, okay, I guess that makes sense, sure. I'm asking it to do more work. And then finally, our fastest performing one on sales order lines was reading an individual sales order line. That's sort of what we expected. I ran the same exact tests against a UAT environment, and if you look, our read is now the fastest on the far right. Our second fastest, and really pretty close to our read operation, is a read expanded operation. So there I'm getting my sales order line details and my sales order header along with it. And I only incurred, 11 milliseconds on average extra overhead. So, I mean, just compare the two. This is dev. This is UAT. So just because it performs or acts one way in one environment type, it may react different. So again, just a call out to test. Next, I talk about read performance and just keeping it simple. So in general, what I've done is Microsoft delivers a lot of valuable entities that do a lot of great things for us, but they do a lot of great things for everyone, everywhere. And chances are where you're working is going to be a specific geographical location with specific business processes. So when you need a data entity to be fast, you copy it, paste it, and then quote unquote chop out what you don't need, and you build it based on whatever it is you need to do. That's largely based on performance, since we're in a performance session. But along with that, when you copy something and make it your own, you have to reconcile any changes that Microsoft may make with each release to that to make sure you're not missing anything. Whether it's, there's revenue recognition stuff that just came out. There's more stuff. They just released the Wave 1 for Wave 1 plan, so there's going to be some new stuff there. We have to reconcile with those changes just to make sure we're getting full use of the functionality that business is going to be using. And lastly, this gives you complete control of your entities, which is a good thing, but as the bad thing, you have complete control of your entities. So there's upkeep with those. So here's an example of just the sales order header v2. And we're going to just step through some of the stuff that you may not need based on where you are in the world or how your organization is configured. So all these pink arrows are stuff that relates to localizations in specific countries that you may not need if your organizations do not operate in those countries. So we've got Italy down at the bottom with base document and then sales table _ BRs for Brazil, and then a few others in there. So if you just copy this and chop that stuff out and make no other changes other than to reconcile that you remove those data entities, you've got a faster data entity. So sort of interesting. Next we've got data. Now here we have data entities in a data entity, which Microsoft has now shied away from because that is basically putting a view in a view. So if you're a SQL person, you can know how that can take something that runs fast to something that takes forever. So in general, don't do it when you're developing custom data entities, and Microsoft is, in general, stop doing it. And then this is just a table, related to TMS that I don't see a lot of end users using. But if you don't use it, you can chop that table out, reconcile your changes. Again, you end up with a faster data entity. I'm going to quick pause to see if we have any questions before I hop into insert.
Yes, we have one question from Juan about, does the use of post-load method on data entities impact performance?
Yes, that's not included in this presentation because I ran out of time. It will be included in the blog post that I posted earlier. It's about 3 weeks out. But short answer, yes, but it really depends on what you're using it for and how you're using it. And again, OData versus traditional DMF, they'll have different impact there.
All right, we don't have any other questions, so you can continue.
Okay. So next we're going to talk about insert performance. This is where I start to unfortunately repeat myself a lot because insert performance on compound data entities, a compound data entity is something that has lots of data sources, lots of code behind it, and performance, scales to the amount of data that you put in there. And when you start running into tests, you're going to start seeing common themes from stuff I've already talked about related to read performance. So I apologize in advance because I'm going to say the same things a lot. But just as a call out, using fewer fields when using a quote-unquote compound data entity is better. And when you add more fields as part of an insert operation, that actually takes longer to write that data. And saving data in a lot of fields increases time as well. And we'll talk about what that means. So first, this is a development from a development or tier 1 environment. I've got 2 things that I'm testing here. On sales order header v2, I've got what I call a concept of a compound maximum and a compound minimum. So I'm using an out-of-the-box entity, and in my maximum workload here, I am specifying as many fields as I can when creating that sales order header. This would be stuff that might be defaulted in from the customer anyways, but if you look at sales order header v2, there's I think 115 or so fields that you can write to. I'm specifying as many of those as I can reasonably get to when creating a sales order header. And on average, when I did that 100 times, it took about 496 milliseconds. So next, I tested what I called the concept of a minimum. You need only 5 fields in order to write that sales order header. So I took that same entity and just reduced it down to those 5 fields that I need just to write a record. And my workload and the amount of time it took just to write that in a development environment basically went to almost half. And that's just down to the amount of data I'm specifying in that. So what that's sort of 2 things: the amount of time it takes to execute code, and the amount of time it takes to persist the data relative to whatever extra attributes you added in there. So this is the concept of a minimum. So here we go. I specified those 5 fields and said save it and track my time there. And then this is the concept of a maximum. So nothing changed. The only thing that changed was I was adding more data, and that slowed things down. So when looking at high performance workloads, if something is taking a while to write, take a look at what you can chomp out, because some stuff will default onto your sales order and you don't need to explicitly specify it. So this quickly turns into somewhat of a functional discussion for what needs to be there and what doesn't. Similar sort of workload. Here I'm just testing against a UAT environment. Here you can see the differences are even more pronounced. So again, just nothing to keep in mind that dev and test may be different. Next, I'd like to talk about what I call simple entities. These just have 1 or 2 tables. This is the absolute minimum of whatever it is required to meet the specific requirement. And these can handle very little code. You're only doing what is the bare minimum to achieve the objective, basically. And these, again, even in a simple entity, these scale to the amount of data being persisted, but that delta is much less pronounced. So here I have, I'm using a copy of sales order header v2 where I've removed everything that is not sales table and specified a maximum, which was as many fields as I could specify when inserting, and I'm averaging the test results after 100. So here, I haven't changed the specific thing that I'm writing, but my numbers have gone down significantly to 194, and here I'm just specifying my 5 that I need, and I'm getting even better performance. But relative to our last tests, these are significantly faster. But we're only writing sales table records, and we're not doing anything with addresses. So again, you guys sort of have to balance functionality versus performance. This is an example of what that would look like in terms of code. And then here's the maximum. Again, I'm just specifying a bunch of fields. And comparing the two, if you look at this, I just want to call this out. When using an out-of-the-box entity, specifying only my 5 fields, that is slower than both of my workloads with a quote-unquote simple entity, whether I'm specifying tons of stuff or very few things. So, again, take a look at what you need to achieve the objective and, deliver that minimum viable product just to meet the need. Next, update performance is very similar to insert performance. So again, if you're updating fewer fields, that's faster than updating a lot of fields. And in general, the business logic and the underlying classes and tables will account for and take care of most of the stuff for you, especially now. So, in older versions of Dynamics, you'd have different things happening, but from different things that may not always execute as expected. Now, data entities are fully encapsulated, or at least have classes that back them to take care of that sort of stuff. But I want to say simplicity doesn't scale quite as well, and we'll talk about that. So again, on sales order header v2, I did 100 update operations by specifying a lot of data, being specified as part of the update, and then similar with here specifying the a minimal amount of data. So same entity, only thing that's changing is data and the way that I interact with it. So here I'm specifying just one field with no validation. I think I'm changing sales name, and then with the light blue line on the left-hand side, I'm specifying 5 fields. So you can see, just keeping it simple makes stuff go faster. And I have a similar sort of story when using a simple data entity that when only specifying 1 field rather than 5, that takes less time to execute, even if it's just on a simple table, the table entity that has no advanced business logic behind it. Next, delete performance is similar to insert and update performance, but this does represent a unique case because you only need to know the key of something in order to delete it. So you can scope on that primary key, then delete, and is that faster? Another question I've gotten is, can I switch entities? So if I'm working with sales order header v2 and I want to dynamically flip to a different entity, how do I do that? So it's super easy, and it's not even an issue. But again, simple is faster than a compound, and a concept of a single entity, and we'll walk through that real quick, is the fastest. What is a quote-unquote single entity? Here it is. So I took a copy of sales order header v2 and chopped out everything that was not sales table and got rid of all fields. So I've got one range with 1 field with 1 key. And that's it. That's all this data entity does. It will say, does the sales order exist or not? And how I use that is, here I'm, just for testing purposes, I'm creating my sales order using the minimum concept, just because I just need to create it. And then here I'm dynamically flipping from that data entity that I used to create that sales order header, and I'm flipping to a different one to delete it. And in the blue box, you can just see I'm scoping it and deleting it. That's it. And what do the performance numbers look like when using a construct like that? So here, on the left-hand side, we've got doing a delete operation with just sales order header v2 entity. So it's okay. It's not great performance. But here I'm doing the same workload with my sales order header v2 entity that was a copy of the original out-of-the-box entity with just sales table. And after 100 tests, the average is 231 milliseconds to delete. Then here, using my single data entity, that is approximately 30 milliseconds faster. But still, it's faster. And why is it faster? Because I'm doing less work. So overall, I think interesting results. And we're coming up on time, so I just wanted to recap. For read workloads, fewer columns is better, fewer joins is better. Read-only, the read-only attribute on the data source and entity is there just for functionality, has a negative performance impact. You want to avoid subselects whenever possible. You can use a select operation to reduce network lag for sets if you need to do that. Alternatively, just make a data entity that represents what you're trying to select and dynamically flip between your customized high-performance entities to do the specific thing you're trying to do. Next, limit the use of order by. You want to sort in the application after you get the data. If you use an order by, use it on an index. If you're going to use an expand, use it where it makes sense, but it is from child to parent only, typically. There's some, asterisk behind that statement as well. Don't multi-thread your OData calls. There's technologies in place that will slow them down or just outright block them. For insert and update performance, fewer columns is better, fewer joins is better, fewer tables is better, fewer fields specified as part of the insert or update is better, and you want to quote unquote create simple entities whenever you can. And for delete, you'll want to use the single entity concept, which is just bare minimum to do that delete operation. And lastly, really, we want to build, measure, and learn, because your results may be a little bit different than mine. I was using Contoso data, so whatever you build, test it, measure it, learn from it, and continue the development cycle to get your performance numbers where they need to be. So, any questions?
Thank you, Nathan, for the great session and providing your analysis on performance and research you did on different entities with the different environments, showing it over here. There are some comments about appreciation about your session on performance. I don't see any questions other than the post-load one. So if anybody has any questions, feel free to reach out to Nathan. He has a series of blog as well. You can ask him questions directly. He has his contact information provided over here. So you can directly email him if you want to know more about anything related to the OData performance.
Yep. And also, I just want to call it, if you want to, my DMs are open on Twitter. So if you don't want to expose your email address, I won't give your contact info to anyone in sales or anything. I just want to call it out. Some people are a bit skittish about that. So if you want to get a hold of me via Twitter, that works fine too.
That's pretty fine. We keep looking you on the Twitter every time, making some nice jokes with Joris and everybody.
Thank you.
Thank you, Nathan. We are right on time. So we have our next session